We said for the previous simulation that we were going to have a 0.3 probability for the visibility, and that seems to be really low, and we're not getting the results that we're expecting. So we're going to have to change that to a better probability if we want to have better results.
So maybe in our system, the way in which we provide synchronization, maybe we need to select a better methodology for that, or a better components, whatever it might be. So we go back, we take an analysis, look at that, we bump up to this better timing system, across the entire network, and then implement that, and then so you'll model this kind of improved model that we'd be looking at to achieve.
Yes, exactly, Mike. That's right. So let's go ahead and say that we have improved our visibility to 90% and run our simulation again. All right, let's see what we get now. Our simulation runs. We see our rounds here. Let's go back to our visualizer and see our results. Configuration file, our third log file, which I believe I called Barrett 3, yes, and we hit visualize. Okay. Alrighty, so let's scroll down, try to find the entanglement and see what fidelity we got this time. So seeing that it's failing, it completed now. All right, so we have reached the point where we have Alice and Bob entangled, and all right, this seems to have improved definitely our fidelity.
Yeah, the fidelity level is much better, and this is a network that I'd feel comfortable saying, okay, we can use this to carry keys across the network to provide a physics-based security mechanism for our communications network, data, voice, and video, of course. And I can also even probably run this for other multi-purpose applications, maybe distributed quantum sensing, or eventually over time, maybe even begin to use it to interconnect and network quantum computers in the future, sometime in the future. So this looks a lot better. This is, just by making these adjustments, giving feedback to the telco, making adjustments to the timing of the system. Obviously we selected a memory in the previous use case that we're using again here. The thing that jumps out at me, a couple things, is one, I noticed that there's things that happen simultaneously with the simulation, which I can now visualize with the visualizer. And it looks as though in between the dashed lines, all the activities that are originating there or terminating there happen at the same time, because they seem like they've got the same time stamp. Am I interpreting that correctly, Michelle?
Yeah, that's correct, Mike. They are happening at the same time.
And then, I think from talking to you before about this, the dark blue communication messages are actually messages that are occurring over the classical channel, whereas the other messages are occurring over the quantum channel. Do I have that right?
Yes, that's right, Mike. We have our quantum, our qubits traveling through our quantum channel, and they are seen here in gold. And then we have our classical messages over our classical channel in blue here.
Fantastic. Well, this is great. I feel really comfortable about this use case now. This is a design that I think I could stand behind as an engineer.